Okay, let's start with your 2D array. Okay, so what happens in a 2D array is we store the data in the form of rows and columns. So this is how the data is stored in. So it's in short, if you can just visualize this. So this is a 1D array, correct? This is another 1D array. And this is another. So how many 1D arrays are this? These. There are three 1D array, and each array, let's say, has a size of 5. How much size? 5. So I have three arrays of size 5, right? So if I club them together, this whole becomes a 2D array. If I form one single unit of them, whole becomes a 2D array. It's called a 2D array. So the concept remains the same, more or less. There is not much of a change in the principles. So what was the index for this? 0, right? Index for this was 1. Index for this is 2. And index is 3 and 4, right? Okay. So now if I form a unit, a cumulative unit of these three combined together, okay, so this becomes your 2D. So the green part is your 2D array. So this is my array. This is my first array, right? My second array, and this is my third array. But as it is an array, the index will start from 0. So this is my 0th array, and this is my first, okay, and this is the second, right? So now my question is, how will you identify each single unit? So how will you identify the blue cell, which row and which column it is meeting at? So it is meeting at which index, intersecting at which column, which row and which? Yes, so you have to show it like this. The row first, 0th row, and column. This is so you identify the cells in a 2D array by two indexes. Okay, if it was a 1D array like this is a 1D array, right? So we identify each cell only by one single index, that is 0, 1, 2, 3. But as in a 2D array, you should now also know x and y coordinates. Okay, so x always first, horizontal first, so it is in the 0th row, and which column? So this cell will be identified as 0, 0. So this cell will be identified as which index? 0th row, and which row and which column? 0th row and first column. And this identified as 0th row and 0th row and second column, right? And this one is 0th row and third column. And this one will be 0th row and fourth. Okay. Now you can put the values. Okay, just remove this. Okay. So now you can put the values for them. So if I want to, let's say, store over here 18. Okay, let me store over here 18 now. Okay, so 18 is stored at which index now? So to declare this array, I will say integer matrix, let's say, and this is a 2D array, correct? So you will put two pairs of square bracket. And what is the size of this matrix? How many rows and how many columns? So this is a 3 by 5 matrix. Okay. Now to initialize this, if I do it by the hardcore way, I will say matrix of 0 0 is 18, correct, and so on. So this will be too laborious. I'll have to write 50 lines of code to initialize the matrix. So instead we use a for loop to initialize this. So the outer for loop will run for the number of rows and the inner for loop will run for the number of columns. And I'll have two variables for them. So I and j. So for I equals to 0, I less than number of rows, I plus plus, and nested loop there. So for j equals to 0, j less than number of columns, j plus. Now in the first iteration, what is the value of I and j? So when I say enter a number and the user enters 18, I want to put 0 at which index? 0 comma 0. 0 comma 0 are with which? They are with. So I will say matrix of. My for loop closes. So this for loop will initialize the array for me, 2D array, correct? Okay, so if I restrict my discussion to just, let's say, size of 3 by 3, so it will be like this, correct? So I'll be having 9 numbers entered, and as mentioned, for array, for every task take a fresh for loop. For every task take a fresh for loop. You're seeing my screen? Okay. Now for this loop will initialize the array. Now to display the array, I'll take one more for loop. So now if I just say printf and percentage %d, what will be the output of this? Any idea? So if I have taken the matrix to be like this, if this is my matrix, the number which I took was 10, 20, 30, okay, so 0, 0, 0, 1, 40, 50, 60. So this is the image in mind which I have of the matrix. So these are the 9 numbers which I entered. Now how do I display them? So if I display them like this, what will be the output? The output of this will be, you want it like this? Is this looking like a matrix? So how should I display it that it looks like a matrix? So when I display a number, I want a space after that number, correct? So it should look like this. Okay, this is looking better than that, but still it doesn't look like the way like a matrix. The first thing is, whenever you display a number, you give a slash t, and as you have displayed the first 3 numbers, then you should go on the next line. You should go like this. So as the inner for loop will break, what we will do is we will give a new line. We will give a new line. So this will display the matrix. This will display the matrix. Okay. So if you want to just print, so this was your matrix A. Okay, we can it like this. Now let's run it, and now enter the, what happened, what is the problem. Oh, we got semicolon after J. Now what is the problem? Scanf, and we did put an and over here as we are scanning, right? Now in printf we forgot to add a T. Okay, enter numbers. So I'll enter 10, 20, 30, 40, 50, 60, 70, 80, 90. So the first for loop will accept it, the second for loop will display it, correct? Okay, now if I want to, in this matrix, I want to find a sum of all the elements. Now what to do? Okay, now again I take a fresh for loop. So I have to put sum equals to 0 now. So how will we add this now? So we have not declared sum. Next what? So you have to add now the 10 to the sum, 20 to the sum, 30 to the sum, 40 to the sum. So how will we add it? Plus sum equal to sum plus of ij, correct? So you can say sum of all elements in a matrix is percentage d sum, right? Okay. What if I want to find sum of only the odd elements then? I'll take a sum odd equal to 0, and then I'll put a if condition over here, that if the matrix of ij mod with 2 is equal to 1, then you add that to the sum odd. And what if I want to take the sum of the even elements also? So if in this, if I can put a else, right? Add it to, making sense? Are you getting it? So and here what we can do is display all three, sum of odd elements, sum of even elements. Odd elements is sumo soon, right? And now declare these variables on top. Correct? Okay, now what if I want to display only the diagonal elements? This is your matrix of 3 by 3. Let me remove the unnecessary indexes. So if this is your matrix size 3 by 3, so what are the, so if this 18, then I give here 20, 30, 40, 50, 60. So if these are my elements and I want to display only the diagonal elements. How will you do that? Diagonal from left to right. This diagonal, I want to display this diagonal. So what is unique about these three elements? If you look, yes, correct. So this 0 is I, this 1 is j, right? So if you want to find sum of all the diagonal, then what will you do? Take a variable called as sum d equals to 0. Yeah, I will do that after that. And what will you check? If your I is equal to j, then what will you do? Matrix of I j, correct? Okay. Now, what if I want to display the sum of the upper triangle elements? These are my upper triangle elements. They form these three. They form the upper triangle, and these three they form the lower triangle. So I want to do some of that also, upper triangle and lower triangle also. Now what to do? Any guesses? What is unique about the upper triangles? Mm-hmm. Yes, correct. If you're 0, 1, 0, 2, and 1, 2, right? So if your j is greater than I, then that becomes what? Sum of upper triangle, and then what will be the lower triangle? No, so we'll put a no, no. If I put a else, no, then those who are not diagonal will go in the upper triangle. If I put a else over here, no. So if I put a else over here, then those which are not upper will go into lower. Even the diagonals will go in the lower. I is, then what do we do? Sum of LT is, right? Then initialize all of them together. Sum UT equals to 0 and declare them on the top. Sum LT, sum UT. Okay. Now let's try to run it. Okay, what happened? And number 30. Some diagonal is not declared. Okay, now let's enter the numbers. 10, 20, 30, 40, 50, 60, 70, 80, and 90. Okay, why is it display only these three? Okay, there are no odd elements, right? Sum is 9490. Odd elements are 0. So, and sum of this is, we have not displayed the other. We have not displayed the other four, no? What are diagonal and UT and diagonal is sum of diagonal is sum of UT, and then over triangle. So like this, you can play around with your 2D arrays. Okay. Okay. Now, if you want to do something regarding to matrix, because we didn't give any odd element, no, all are 10, 20, 30, 40, 50, all are even, no. All the numbers are even, no? That's why it is giving odd. So now, if we want to do some operations on matrix, okay, I'll just copy this and paste it to share later on. So if I want to do addition of two matrix, how will you do that? So if you have two matrix, size one, this is other two matrix, 1, 2, 3, 4, and 7, 7, 6, and 8, 4. So now how will you add them? Yeah. So what will be the addition of that? Addition will be 8, 8, 11, 8. Right? So how will you do that? So how many matrix will I require for this? 3. First, second, and the resultant matrix, no? So I'll say matrix 1. What is the size? 2 by 2. And similarly, matrix 2 of 2 by 2. And if you add the matrix, the resultant should also be the same size. Matrix 3. Correct? So now we'll initialize the first two matrix on the user, and third we will calculate. So we will say enter elements of first matrix. You will enter 4 elements and they will be stored in the first matrix. So I will go from 2 to 2, correct? Matrix will be initialized matrix 1. Similarly, we will do it for the second matrix also. Then we will display the first matrix, matrix A. So go to 0 to 2, 2 to 2, and we will say matrix 1 and print it, correct? And then second we will do matrix B. Just change it. Now, if I want to add them, what we will do? We need to initialize anything. Directly, what will we say? Matrix of 3 of equals to matrix 1 of ij, 2 of ij, right? And then we will come and display the matrix 3. And we will do the display of the third matrix. Matrix. We will do matrix 3, correct? So now if I do 5, 6, 7 and 8. So it will be 1, 2, 3, 4, 5, 6, 7, 8 and matrix C is correct. Okay. Now if I want to do a program wherein I will do matrix multiplication. This is a bit tricky. How do we do matrix multiplication? So see, if I have a matrix, let's say I'll just, so if I have a matrix 1, 2, 3 and 4, and I have a matrix 5, 6, 7 and 8. How do I multiply them? What is the ruling to for matrix multiplication? No, no. What we do is, see, this is which row? Matrix A, right? This is my matrix A, this is my matrix B. So ruling is first you have to find the ABCD rule. Which rule? ABCD rule you have to apply. ABCD means the A means the rows in the first matrix, number of rows, a number of column in the first matrix, number of rows in second matrix, number of column in second matrix. So tell me, what is A? 2, B is, C is, D is 2, right? If your B and C is same, if your B is and C is, then only the matrix can be multiplied, else not. So is B and C same over here? It's same, right? Can we, yeah. So is the B equal to C over here? So the matrix can be multiplied. It is possible, right? When it is possible, what will be the size of the resultant matrix then? So the third matrix which will be there, that is the A into B matrix, right? So what will be the size of that matrix then? That matrix size will be A into D. A into, so the third matrix A into B will be a 2 by 2 matrix. Will be a, now see, if I give you this is a matrix, okay, assuming. Now can you multiply these two matrices? Yes or no? Tell me. So put into the A B C C D rule. What is A? What is B? What is C? What is B? D? 2. Can these two matrices be multiplied? What will the size of A into B then? It will be a 2 by 2 matrix. Getting it? So first thing first, we have to, okay, when the rows and the columns both are same, it is called as M into M matrix. What is it called as? This is the M into M matrix, right? And when the rows and columns are different, it is called M into N matrix. It is called as M into N matrix. So if I want now to multiply 2m into n matrix. So I don't know the size of the columns, right? So how will we do that? So what I'll do is I'll take two matrices of sufficient size. Let's say I'll take matrix of size 10 by 10. What size will I take? Okay, what size will I take? Matrix have, okay, 10 by 10. Then I will ask the user to enter me the ABCD, means row 1, column 1, row 2, and column. Okay. So what will I say? Printf new line. Please enter number of rows of matrix 1. Okay. So scan it in which variable? And R. Correct. I copy paste this more times. Yeah, but I prefer doing it individually to make the program more readable. Yeah, you can do it. Yeah, if you want to do this number of rows and number of columns, you can do it like this. So C1. Okay, so if you want to do this, you can do it, and then matrix 2 will go into R2 and C2. Now, when is the matrix precision possible? If your C1 is equal to R2, right? Then we will do all this stuff, whatever we have to do. Else, straight away we will say multiplication not possible. Correct? So if those two are same, then we will do the activities of accepting the matrix and all that stuff. So now we'll say enter the element of the first matrix. So first matrix element will be from how many rows? R1 rows, right? How many columns? See, okay. So now we are not hard coding the values. Now we are taking from the user, and then that we will accept that matrix. Mm-hmm. Where? Yeah, the three matrix we have taken is the same. Name is same, no? Matrix 1, 2, 3. Okay, so that will go the first matrix. Second matrix then again will be R2 C2 and you take it. Okay. Now our matrix multiply. Now we display them. Okay. So R1 and C1. Matrix B R2 and C2. Okay. Now displayed the matrix. So now how do we multiply the matrix? It is the formula is like this. So if I have these two matrices, I put them up and so now what will be the say size of the third matrix? as per the ABCD rule, this will be 2 3 3 2, right? Matrix will be of size 2 by 2. Put this, so 2 by 2 means 2 rows. So this is the first row, this is the second, right? So this entire matrix will be, so this, so if the answer is, let's say, 100, 200, 300, 400, so that is 2 by 2 matrix, correct? So what I do over here now is take this first row, take this first row, okay, and multiply it with the first column over here. Take the first row and multiply it with the first. So what is the first row? Yes, am I audible to you? Yes, I am audible now. Hello, Aryan. Hello, I'm not able to hear you. Hello, Aryan. Yeah. So now what we do is we take the first row and multiply with the first column. So 1 into 1, 2 into 3, and 3 into 5. And you add. So what we have to do is take a sum variable, initialize to 0, and then what we have to do is do 1 into 1. Do what? And what is the answer? Add it to this sum. So this sum becomes 1. Then we have to do what? 2 into 3. What is that answer? Add it to this one. So this becomes 7. Then we have to do 3 into 5, which is 15. Add it to this 7. That becomes 22. And now once this breaks, then this 22 will come as an answer over here as my first number. Correct? And my sum will again become 0 for this second. Again sum will become 0. Now I will take first row and second column. First row and, so what I will do is 1 into 2. So 1 into 2 is what? Add it to the sum. So sum becomes now 2, correct? Next, what will be? Next, what will be there? 2 into 4, that is 8. Sum becomes 10. And the next will be 3 into 6, that is 18. The sum becomes. So put this 28 over here as my second number. So how many times will this be done? This will be done. So the resultant matrix has how many rows, how many columns? The resultant matrix has how many rows? R1 into C2. So my resultant matrix, you see over here. So we'll start from, we'll go R1 and this will be till C2, correct? And now what was the what was the common value? B and C were common, right? So run a for loop, third for loop till that. So k equals to 0 and k less than. So B and C was same, right? So you can take any one. So you can take C1 also. Are you getting it? And now what we have to do over here is, make the sum equal to 0 over here. Okay. This loop will run 4 times, right? This loop will run 2 times. This will run more 2 times. So to do 4 times, this loop will run. So sum will become 0 times. 4 times. And here what I will do is sum equals to sum plus, I will say, matrix 1 of I k. Matrix 1 of what? I, and multiply with matrix 2 of k and j. Matrix 2 of k and j. So 0 0 with 0 0. Then over here the first one. So this 1 with 1 is what? 0 0 with 0 0, correct? Now 2 with what? 3. So 2 with 3 means 0 1 with 1 0. So this number is common. This digit is always common, right? So I and K and J. I and K and K and J. Getting it? So whatever that comes up, I'm adding to the sum, and once this for loop finishes, I will put that sum at matrix 3 of ij. Getting? Once I calculate the sum, I'll put that sum at the matrix 3 of I and j. And then we can go and display the matrix C, which will be from where to where? A to D, right? R1 to C2. Getting it? Okay. Now let's try to run this code. So if I have a simple matrix, let's say this one. So what is the answer of this? 22, 28. And now 4 into 1, how much? 4 into 1 plus, so let's just do it orally. 4 plus 5 into 3, 15 plus 6 into 5, 30. How much? 49. And let's do this orally. 4 into 2, 8 plus 20 plus 36. How much? 56 plus 8, 64. So now if I give now what is the size of my first matrix now? 2 by 3, correct? by 3 and 3 by 2. So now let's try to. So now, oh my, we haven't declared everything. We haven't declared some. We haven't declared some. It looks like. Okay, let's try to run it now. Okay, so K, we haven't declared K also. Okay. Okay. First matrix. What is the number of rows and columns? 2 and 3. And second matrix. Okay, so as multiplication is possible, it is showing me this. So if I would have run any entered any random data, then if I would have just done 2 and 2 and 3 and 3, is it possible? Direct what it would tell me. Okay. Now it is possible, right? So 2 and 3 and 3 and 2. What is the first matrix? 1 2 3 4 5 6, right? 1 2 3, both are 1 2 3 4 5 6. 1 2 3 4 5 6, both is the same, right? So 1 2 3 4 5 6, and here also 1 2 3 4 5. Now it is displaying you the two matrices. Matrix A is this, matrix B is this, and matrix C is the 2 by 2 matrix. Getting it? So this is how you play around with your matrices. Okay. So this was all about how we can play around with 2D arrays. Okay. So anything you want to discuss?